Building agentic AI applications is hard, really hard. And if you want to do it well, you need proper evaluations in place. And this video will show you everything you need to know to get started, and you'll learn how to think like a true AI engineer. And despite what everyone is showing off in your timeline on social media, we have big companies like Gartner and MIT coming out with reports that by 2027, 40% of all agentic AI projects is expected to be cancelled. And MIT, 95% of all generative AI pilots are failing. Now, are these numbers accurate or inflated? I don't know, but what I do know is that there is a truth in them and a lot of lessons that we can learn from this. And I want to help you to become a top 5% AI engineer who does know how to reliably ship agentic AI applications and how to systematically improve them over time. So in this full crash course on LLM Evals, I'm going to pull back the curtain and I'm going to introduce you to the strategy that we use at Datalumina to systematically set up all the evals for the AI projects for our clients. And now the training you're about to watch is actually coming from our GenAI Accelerator program, which is a 6-week course to help developers go from basic Python understanding all the way to a production-ready AI engineer. Now make sure that you pick the right moment to go through this training, because this is not just some YouTube video they can watch casually. No, this should be studied, because we have a lot to cover and we'll go really deep. We'll start with some slides and some theory, the essential things that you need to understand about the 3 levels of LLM evals that we currently see out there. Then we even dived into some tools that I will make available for you as well. And of course, we'll go through some code examples, which you can also get access to. And now in the description below this video, there will be a link that you can use to access all the resources. So I'll add you to the private GitHub repository, I'll share the Excel tool with you, and I'll also share all of the PDFs slides with you. So with that introduction out of the way and you knowing how to follow along with the resources, let's dive into the training. Hey, what's up? Dave here, and welcome to this video called Introduction to LLM Evaluations. Now for this one, we're going to go back to the slides one more time, because with this topic, we first need to cover some theory before getting into some of the code examples. So this video is going to serve as an introduction for the following videos in this week that will come around all things evaluations. So to kick things off, let's start with the following questions over here. Because when we talk about LLM evaluations, it's first and foremost very important to understand what can we use LLM evaluations for. And essentially, what it can do is it can help you to answer some of the following questions that every AI engineer will ask at some point when you're building with LLMs. What will happen if I adjust the system prompt? How do I know if my RAG pipeline is working correctly? Are we performing the correct classification step? Besides factual accuracy, is the tone of voice on point? How will this behave with real user inputs we haven't seen yet? Are we catching unsafe or problematic outputs? How do you know when the system performance is degrading in production? Or is our system robust enough to flag prompt injections? All questions where right now, if you were to simply build the workflow, put it into production, and then let it run, you will likely have no idea how to tackle these questions. So some can partially be covered by the LangFuse integration and then simply looking at a lot of data. But that's you can only do that to a certain degree. And with that, you can essentially only flag issues as they arise. So as things go wrong, you can go in LangFuse and track and see what essentially went wrong and then try to fix it. But how do you know that a change or a fix in one part of your application, for example, changing a system prompt, is not creating more holes at other stages of your system or other cases or other data flowing through your system? So that's where evaluations come in. It helps you to tackle the core challenge that we have to deal with LLMs, which we are fully aware about right now. So these LLMs, they're non-deterministic, subjective to context. A response may be factually correct, but the vibes are off. An answer or question can also have multiple valid responses. And failure modes are subtle and hard to predict. So this brings us really to the core question. How can we effectively evaluate AI system performance and identify specific areas where improvements are needed? An LLM or an AI application is never truly finished. You can always optimize the prompt even further to get it just a little bit better compared to what it was before. So that is really the main challenge here. And if we then look at that core question, and how we can deal with it essentially. If we drill down, there are three kind of like sub-problems that make up this entire big question of how can we effectively measure AI system performance, etc. So the three core challenges in LLM development are the following. So first of all, there is an understanding of the data. So when you build a workflow and when users start interacting with it, you realize you don't understand what's actually happening at scale. What are users asking? How is your system responding? What are the edge cases? So this is a challenge around the data, where when you run these examples, as you've also seen throughout us working with the project that we're working on, right? You test isolated examples, often very simple examples. You test the happy path of what happens when you think how users will interact with the system. But at scale, this is going to be drastically different, and users are very, very unpredictable. So it's first of all about a challenge about understanding the data that's flowing through your system. Now, then it's about the specifications and more specifically the gap within there, because there's also always a gap between what you want your system to do and what you can actually specify in your prompts and code. So you know a good output when you see it, but translating that into clear instructions can be surprisingly hard. So for this, think about the example within the customer care domain, right? If you see a user question and an answer, it's for us as humans pretty easy to spot and identify whether it's an appropriate answer, especially if you know the business context. But then thinking about, so if you identify, okay, it's a bad answer, what actually caused that? Is it a prompting issue? Is it a retrieval issue? Is it a combination? Is it an error really in your pipeline logic? Those are all components that you need to be able to understand so you can essentially close this gap between what you specify and what the model does. And then there's the challenge of inconsistent behavior. So your LLM works great on your test cases, but then behaves unpredictably on real user inputs. Small changes in wording can lead to completely different outputs, making your system feel unreliable. So subtle nuances, subtle changes in how users ask a question or how a customer care ticket is coming in or how a particular document is processed can make all the difference. So these are really the three core challenges in LLM development. And your success when it comes to building AI systems really depends on how fast you can iterate. Because like I've said, the first version that you make, the happy path that you test with your examples, this is never the final stage. Iteration and continuous improvement is a non-negotiable. It should be part of every AI development process. And there are, again, three key critical components that you need to consider. So your success depends, first of all, on your evaluation quality. So do you have systematic measurements of your workflow performance through, first of all, automated tests, human evaluations, and other success metrics? Can you properly debug issues? So do you have some tools or some scripts that you can use to understand and diagnose failures, including trace logging, data inspections, and error analysis? Now, LangFuse is a big component that solves this middle part already for us. And then change behavior. So do you have techniques and do you understand your system well enough to improve your system based on insights from evaluation and debugging? So can you look at the data in LangFuse, spot when something goes wrong, and then understand how to adjust your workflow in order to solve that particular problem so it doesn't happen anymore in the future? So most teams only focus on number 3, which prevents them from improving beyond a demo. Doing all 3 creates a virtuous improvement cycle. So all of these 3 need to work together in harmony in order to be in full control of everything that's going on in your AI system. So that then brings us to evaluations. What is it? And in the most simple definition, really, an evaluation is a systematic measurement of quality in an AI system. And evaluation is typically shortened to evals or an eval. An eval is a single metric that measures a specific aspect of performance. So your AI system can also have multiple evals. So you could, for example, check your responses for factual accuracy, tone appropriateness, following instructions, or output format compliance. And evals can be operationalized in the following 3 ways. So they can be running in the background for background monitoring, so tracking performance over time. You can implement them as guardrails, so you block bad outputs in real time. And you can use improvement tools, so you can label data for either fine-tuning or for just creating custom data sets to create your own suite of tests around these things. And how you apply this in practice in the real world is following the analyze, measure, improve life cycle. And this is a concept that we've been applying at Datalumina already since the beginning of the AI project that we've worked on. But I recently came across an article from a course that I've been following. It's from Hamel Hussein and Shankar, who on the research paper is called Application-Centric AI Evals for Engineers and Technical PMs. So this is a report that they're working on as part of as a paid course. So I cannot share the full article with you, but I took the following life cycle out of this because this is exactly how we are doing this, and also a good mental model that you can keep in mind as a cycle for how to improve this. So this iterative cycle addresses the 3 core challenges that we've identified. So data specification gaps, and then the inconsistencies really, through systematic evaluation and creating a flywheel for continuous improvement. So what you want to do is you want to start by analyzing everything that's coming in, everything that's flowing through your system. So collect examples and categorize the failure modes. This is something you can do in LangFuse. Now, in the real world, how this is likely going to happen is this is either users complaining about your system, you looking at data and then spotting errors, or simply having real errors in your system and getting application errors. So for example, your code crashes or it's not running or outputs are not stored correctly. All failure modes that you should analyze and collect. Then number 2 is measure. So you want to translate these insights into quantitative metrics. So they come at various levels. So you can have quantitative metrics as simple as Boolean values, pass or fail. But we can also add more specific metrics to this and even create some rankings, so scorings between 1 and 0 or 1 and 10. And then it's improve. So you want to refine your prompts, you want to play with different models and your overall architecture that you're using. So this is the workflow that you are working with. So now that you understand the high-level approach, let's drill down to the 3 levels of evaluations and make this a little bit more practical, also with some examples. So if you go from left to right, you see level 1, 2, and 3, and the cost and effort increase with each level, dictating when and how often you run them. So at level 1, we have the most simple form of evals, and those are simple unit tests. Now, these are tests that you may already be familiar with from just software engineering projects in general. Any serious project should have unit tests around them to see whenever you make changes to the code if all of the core functionality and features still run. We'll have a dedicated video on how to set up unit tests, and I'll show some examples in a bit. And these are really fast and cheap assertions that you should really run on every code and prompt change. Then we have level 2. And this is where we get to human and model evaluation. So this is really a systematic review, an automated critique of quality. And when you have a production system, you ideally want to run, depending on the complexity and size of your system overall, you want to run these weekly or bi-weekly. There's a little bit more cost involved in here because they always go hand in hand. You cannot, especially not in the beginning, fully outsource this to models and automate it. You need humans in the loop here as well, so that it can be costly in terms of just humans having to spend time on this. And then when we get to level 3, we get into A/B testing. So this is where real users experiment to measure business impact. And this is something that you want to run with major releases, or when you really want to set up proper experiments to, for example, compare 2 different system prompts. The cost for this is a lot higher generally because you ideally want to gather a lot of data and not just go off of a couple of 5 checks where you run a couple of examples, you feel like, oh, I think option B is better. So let's get into some examples on all of these 3 tests. So level 1, the unit tests. Again, they are fast automated assertions. And for those of you new to Python or who have never worked with assertions, You can do this in Python by looking at the left the right image over here and using the assert variable. So if you put assert in here, everything else that comes after that, if that equals to true, so it should be a Boolean statement. If that equals to true, Python will run it and it will not throw an error. If everything that's after the assert results in a false outcome, Python will give an error and you can catch that. Now you can also negate that by using the not, but you want to create Boolean check marks and use the assert around this to monitor your system. So how this then works for large language models is the most straightforward way to do it, and what we typically include in all of our projects is creating unit tests around structured output. So a really simple example here is, let's say you have a ticket coming in. My credit card was charged twice this month. Then you have a workflow step that categorizes this ticket. Like we've seen in the program already, we use structured output and we categorize it. That now has an output, so we have a result.category. We can now create a few assertions. So first of all, we can check whether the category is in all of the categories that we have identified. So let's say we have 3 options: billing, technical, general. Let's first check if it's generally within this list. Now also let's assert if the confidence score that we also created with this is a float. And now also let's check whether that's between 0 and 1. These are all simple tests that we can now create, and then we make it specific for this input, and we want to create a test where we say the result.category for this particular ticket should be billing. Now, what you can then do within your code base is you can create a simple folder, and we typically put these in the evals folder, and then we have some events in there or examples, and we store raw events in there. So we use the JSON data that we collect within our database. This comes back to why it's super, super crucial to capture all of your raw events. So you can easily go and grab those JSON events. You can plug them into your code base, and you can simply create some Python tests similar to what you see over here, create some assertions, and then every time you make some major changes, you just want to run everything that's within that folder. Later in another video, I'll show you exactly how to set this up, but that's really at the core what you can use unit tests for. You can pretty much go as far and as deep as you want with this and consider what makes sense for your system to test. How do you know what to test? That will come from the failure modes, and you'll get a feel for that over time, because when you run into errors and you spot those, you then see, this went wrong. How can I create a test around that to make sure this never happens anymore? All right, then let's get to level 2. This is where we get to human and model evaluation. And there are some common misconceptions around this. And most people, when you talk about evaluations, they immediately think that you should use some automated software and tooling for this, where you use an LLM and you give it some instructions in a prompt, and now you just let that monitor your whole system. Like, that would be the dream, and that would be super helpful, but in theory, that's not how it works. And that's pretty much what you want to avoid in the beginning at all cost, because you want to make sure that the way you are setting up your evaluations, your evals, is aligned with how a human, ideally a domain expert, looks at the data and would evaluate the system. Because how can you instruct an AI model with a prompt to do a review if you have no idea what to look for and how to score these inputs and these outputs? So when you move beyond level 1 tests and evaluations, so the unit tests, you want to get humans in the loop. So you want humans to look at data. So depending on the project that you're working on, it could very well be that this is you in the beginning. You as the engineer. But when you're working for a client, for example, you also want to get those domain experts in the loop, and you want to make them aware of the fact that they need to look at data. So you want to remove all friction from viewing data. And you can build some custom tools for your domain even. So you can build simple low-code, no-code dashboards, but an Excel sheet will already go a long way, which I will show you in a bit. And you can also use lang views for this, which we'll have a dedicated video on in this week. So in the beginning, you want to look at as much data as possible initially. Also use an engineer because you need to understand what's flowing through your system and how users are interacting with it, but also the domain experts. And you want to save good examples for later reference. And then only when you get a good feel for how a human would evaluate your system, that is where you can turn to what is known as an LLM-as-a-Judge, where you use a language model to create these evaluations for you. So you use an LLM to critique your system's outputs. And for this, you typically want to use the most powerful model that you can afford. So this is not for the GPT-4o minis. This is really for the GPT 4.1s, the Claude 4 Sonnets, or whatever the best model is at the current time that you're watching this. So here you want to focus on specific quality dimensions. So this comes back to your system can have multiple evals. So you can start with good, bad, but you can make it more specific. Also on, is it factually correct? Is it helpful? You can decide for your system what makes sense to critique on. And you want to generate detailed critiques, not just scores. So beyond just good, bad, also let the model explain why it is good or bad. And this is super critical. It must be aligned with human judgment. You cannot skip the human eval step and go straight into using a model to evaluate your system. And you want to track human model agreement over time. The more you put human evals really into the system, the easier it's going to get to create model evaluations, but you need to continue to track this over time as well. So this is also not something where it's like, okay, let's do this for the first 2 weeks and then we're done. Then we have a fully automated system. Your system and your data will experience drift, where over time, either due to prompt modifications, data modifications, different features, different users, there's going to be a drift in what good looks like and how these evaluations should be set up. So they always go hand in hand, and human evaluations lead to model evaluations to align them. That's really the goal here. And you want to track correlation and iterate on a judge prompt until it agrees with humans. Now, how do you create these aligned evaluators? Because right now you might be, okay, this makes a lot of sense. We first go and let humans look at it, then we use a model. But how do you actually do this in practice? We'll also have a dedicated video on that, but I'll give a short example with the general alignment process that you can consider. So in order to build automated evaluators that think like human experts, here's the process. First, you collect model predictions, you generate model critiques, you get human evaluations on the same data, you compare model versus human judgments, you iterate on the evaluator prompt, and you repeat that until you have sufficient agreement. So what a very simple judge prompt could look like, and in the real world, this would be a lot more extensive, but let's consider the following. Evaluate this customer service response on these criteria. The accuracy, are the facts correct? Helpfulness, does it solve the customer's problem? Tone, is it professional and empathetic? Provide a detailed critique explaining your reasoning, then rate either 1 or 0, good or bad. And pro tip, you want to start really with the binary ratings and detailed critiques. Use the critiques to understand disagreement and refine your evaluator. And now, to make that super practical, here's the actual process. And this is probably where everything starts to click and where you can start to see how this is all coming together. So I mentioned that in the beginning, it's super important to just use simple tools and something that you already have available. There are dozens and probably hundreds of tools on the market right now that promise you to simplify creating evaluations. And it's super simple to plug that system and connect it with your system. And you can use an LLM, have some prompts, and then you can get all kinds of scores on accurateness, on correctness, and you have these beautiful dashboards. But the reality is that those metrics really are absolutely useless if you don't fully understand what is important for your system and how a domain expert or a human would critique the model outcomes. Only once you go through this exercise can you optimize the prompts in such a way where you can do these things automated. and you want to keep it as simple as possible in the beginning. That's why I say focus on binary examples here first. So what you see over here is a simple Excel file, and this is also something that we've used with our clients, where in order to get to automated evaluations, we first collect a sample data set. So in here, I have 10 examples. So you can see things like, my order is 3 days late. Where is it? How do I cancel my subscription? Now, ideally, these are real questions, so real raw events that flow through your system. But in the beginning, you can also use synthetic data. So LLMs are also super good at creating synthetic data sets. So in the beginning, if you don't have 100 examples already, just create 100 examples based on what you think the type of data flowing through your system will look like. And now, here's the key to making this work. What you now want to do is you want to then run it through your system. So you want to run it through your workflow, and you'll have the model response. So when the input is, my order is 3 days late, where is it? The model says, I understand you're concerned about your order. Let me check that for you right away. Can you provide your order number so I can track its current state? Now, that could be a valid model response. Now, then here's the second step. So these A and these B columns, this is a data set that you want to capture before. So ideally, you want to have 100 input examples also tied to the 100 outputs after they, essentially the output from your workflow or system. Now, then we get to column C. This is where we create, or let an LLM create the model critique. So we are now going to loop over the data within our data set. So these are input-output pairs, and we'll create as a prompt for that. So for example, the example judge prompt that you saw over here. And now for all of these 100 records in here, we're going to let the model critique it, and we're going to give it a score or an outcome. And you can use structured output for this. So think in terms of a Pydantic base model critique, and then its explanation. And then you have the model outcome, which is, let's say you make it a Boolean or you make it a literal, true, false, pass, fail, structured output. And then you create a system prompt on how to critique this. Now, when you run that, the model will then give all of that critique. So you can store it in the database as well. You'll have the model outcome. So for this first record, model said, you know what, this is a good example. This looks good. Then here on number 6 over here, it says the model said this is actually a bad example. And then here it explains why. Now, in parallel, this is important, this is in parallel, you want to do the same process, but you want to let a human do it. So you want to have an actual human look at this input and output pairs and really consider, given our system and the problem that we're trying to solve and the users that we're helping, is this the type of output that I want to get from our system? And then, for example, you could say this response is too casual for a 3-day delay. Customer said late, which implies frustration. Should acknowledge the delay is unacceptable and show more urgency. Also should proactively offer compensation discussion. So the human said, you know what, this is bad. And as a result, we create a simple check mark where if they match, if the model if the human outcome matches the model outcome, we have an alignment of 1. If there's not a match, it's a 0. Now, we can then in parallel perform these LLM evaluations, and we can do the human evaluations. And now we can see an agreement score that we have in the top right corner over here. That for these 10 examples in here, there is a 70% agreement score. Is that good? Is that bad? Depends on your system. Ideally, of course, you want to create as high of alignment as possible. So now what you can do in the next iteration is the human critique remains the same, because this is really your golden standard, because this is what you want to optimize it for. Now what you can do is you can either manually tweak the prompt for the model critique, or you could even use some meta prompting for this. And this is super powerful. This is actually what I would recommend. So you can make an export of this data set, and you could then create a meta prompt. So you could go to use one of the most powerful models. Say like, look at these examples over here, input, output. Look at the human critique and the outcomes. Now here are the model outcomes, and we can see that there is a 70% agreement in this, where some of the model outcomes don't match the human critique. Here is the current prompt that we're using for the LLM-as-a-Judge. Please help me optimize the prompt so that the next time we run this system, we get as close to complete agreement as possible, ideally 100%. And what the AI will now do is it will start to look at these discrepancies and start to spot the patterns in the human critique in here and see, okay, the human favors or finds it more important to pay attention to these particular aspects. And now it will integrate that into the model critique prompt. And now when we run that one more time, you can have another sheet, iteration number 2, different system prompt. And now you can see what the effect is on the agreement score. And now ideally, if you do this correctly, it should go up. This process that I am explaining to you here right now, this is the most fundamental and the most critical component to improving your LLM applications over time, getting human critique and then creating an aligned LLM-as-a-Judge evaluator for this. And almost everyone wants to completely skip this part and immediately use some fancy off-the-shelf tool to get to this point. It's like, hey, you know what? I don't have to look at data. I just have a simple prompt. I have these 5 metrics in here. And now for every data point that runs through my system, I have this nice dashboard with 5 scores, and I can just track it like that. But the reality is that you as an engineer have no idea of the data that's flowing through your system. So that is really a big red flag for you to look out for. This is a process. This takes a lot of time, but it's super crucial and something that's completely different from regular software engineering. This much more relates to the approach data scientists and ML engineers are used to, where you have to continuously run experiments in order to get your final metric, in this case an agreement, to get it up by percentages every time you make a tweak and make an adjustment to the overall system, where you really need to understand the nuances of what is happening within your system, what the inputs are, what the outputs are, and then what good looks like. So then that was an extensive one. Now let's get into level 3, and that is A/B testing. So this is the trickiest of all of them. And this is where you are going to run specific tests to either compare, for example, different prompts, different models, or even completely different workflows to measure the impact really on the outcome of your overall system. So what you can now, for example, do, and there are a lot of ways to do this, but you could, for example, create an A/B test on a specific prompt or a specific model, and then also pair it with this system in order to figure out what essentially results in the highest overall score of good and bad examples. So this is right now, the metric here is agreement, but you could also look at, if we look at the human scores in here, so we can see the human is 1, 2, 3, 4, 5, 6. So there's a 60% score really of good, bad within this system. Now you can compare that as well with a different prompt and then see if it scores higher, if there is a better overall evaluation from the human perspective and then later from the LLM perspective. Or you could also really embed this into your application where users can give feedback, for example, by giving a user satisfaction rating or giving a thumbs up or a thumbs down. So this is super challenging to implement. And we at Datalumina, we haven't even gotten to the point with our applications yet where we really have automated A/B testing based on user satisfaction. We still run all of our production processes really using the following, where we do small A/B tests on prompting, but not where we fully have user satisfaction rating in there. That's all possible, but it can get super complex and only really makes sense when your application gets to a mature enough level where so many users are using it. And you really want to be super mindful of even the tiniest little adjustments that you make to, for example, the system prompts in your system. So here you can measure things like user satisfaction score, task completions rates, time to resolution, user engagement metrics, or business outcomes, sales and retention. This process should give you the foundation to understand how you can measure really the impact of what an A/B test could look like if you want to do that fully internally without having a full user satisfaction or feedback system in place. So that covers the 3 levels of evaluations, each getting more and more complex and also costly as you go up in the levels. And now let's cover the types of evaluation metrics that you can use. And I recommend for everyone, start simple, start binary, good, bad. That is already challenging enough to get that up and running. But when you want to go a little bit deeper, there are first and foremost 2 important major categories to consider. And the first are our reference-based metrics. So this is where you essentially know the golden answer. You know what good looks like and what the output should be. So you can simply compare it against that. So you can either do exact string matching, semantic similarity, code execution results, SQL query correctness, or structured data validation. These, as you probably understand, are easier to pull off because when you have a golden answer, when you know what the output should look like, it's fairly easy to create a test around that. And a lot of this can also be captured with level 1 evaluations using unit tests. But often in the real world, what you'll find is that you'll be working with a lot of reference-free metrics where you don't entirely know what the correct output really should be, or there can really be multiple outputs that are correct, right? So for example, answering a customer care query, there are probably infinite ways to give an answer to a particular question, which could all be good, right? There are just different ways of how to get to that answer, different tones, different lengths, etc. So these are the things that you can then also create metrics around: tone appropriateness, length constraints, no hallucinations, format compliance, safety and toxicity. Now, these are all metrics that you can then also create some kind of a scoring around. So typically what you'll find is that you'll have metrics between 1 and 0 or like 1 and 5, where tone appropriateness, like a 1 would be perfect, like 100% match between how you feel the tone should be and what it actually is. So these are a lot harder to implement. Now, when we get to the LLM-as-a-Judge part on really how to implement that, I'll show you examples of how you can set this up. And for now, I want you to just be aware of these 2 types of metrics that you can play with. And what you need for your system is really going to depend on the use case. So then let's cover some of the common mistakes to avoid. So the first one is tool-first thinking. So do you experience problems with RAG? Oh, let's go to a new vector database because that is probably going to solve my issues. Do I have an accuracy issue? Oh, let's use a different model. Let's use a more powerful model. Need a metric? Let's buy an eval platform that gives us 10 metrics out of the box. And now the fix for this, just start simple and build custom solutions based on what you need. Mistake number 2, generic metrics obsessions. So drowning in meaningless scores, helpfulness 4.2, truthfulness 4.5. What does this actually tell you? Fix, focus on specific actionable metrics. Start with booleans. Build your metrics really based on what you want to know from your system. Then mistake number 3, avoiding your data. Oh, we can just use a tool for this. Oh, the LLM will check it. Real user will tell if it's broken. Trust your gut or go with vibes. Fix, look at lots of real data constantly. This is so important and something I see a lot of AI engineers, especially coming from a software development background, simply ignore. I recently heard this anecdote of a principal engineer at Zapier who spends 3 hours per day looking at traces and data. So that engineer is paid to write code, to build software, but knows the crucial importance of looking at data and that you cannot fully understand, thus nor improve your AI systems when you don't understand what data is flowing through your system and how the prompts and the models are interacting with that data. So don't avoid skipping this crucial component. And this is also something that never stops. You should always keep looking at your data. How to look at your data? Make sure you track everything in LangViews or any type of other platform that you want to use, but I recommend LangViews, and then look at those traces. And then mistake number 4 is unaligned LLM judges. So by now, I think we have already covered this point, right? So you cannot just assume the judge works. You need a validation process because you want to be able to understand what you're judging against, right? And what you're optimizing for. So fix always validate judge alignment first by bringing a human in the loop. Okay, and then to wrap up this video, let's cover the key principles for success. Start simple and specific. Focus on your biggest problems first. Use existing tools before buying new ones. Build domain-specific evaluations. This is different for every project. Start with unit tests and manual review. This will get you really a long way. Look at lots of data. Manual inspection has the highest value to prestige ratio, really. You're doing it wrong if you're not looking at data. Sample broadly, then focus on patterns. Never stop examining real examples. Remove all frictions. Make viewing data effortless. Build custom tools for your domain. Automate repetitive evaluation tasks. And track metrics over time. And then finally, only use LLMs to scale. Generate test cases automatically. Create synthetic data at scale. Automate critique and labeling, but always validate with humans. All right. And with that, we have come towards the end of this introduction to evaluations. And while keeping all of this in mind, you want to work towards really an evaluation-driven workflow. You want to create a system where improvement is systematic, not accidental. So you'll know you're succeeding when you can deploy changes confidently. Failures are caught before users see them. You understand your system's behavior, and improvements compound over time. And you're struggling if every fix breaks something else. You're surprised by user complaints. Progress feels like trial and error, and you can't measure if changes help. All right. And with that, we have come towards the end of this introduction to evaluations. I think one of the most important videos and concepts to understand out of this entire program, because everything that we've covered up until this point are really the fundamentals, what really helps you to get started, to start building. But this is the process that happens in the real world and where you can make the difference between an AI app that can only follow the happy path and works in some cases versus having a system in place where you can really beat the competition because you can systematically improve your application over time. All right, congratulations if you made it to this point in the video. We already covered a lot of theory, and by now you should already have a really solid understanding of how to set up your LLM evaluations. Now, before diving into the code examples, I want to remind you one more time, if you want to access the resources and also get access to the private repository that we'll use in the next examples, as well as the Excel tool, make sure to check out the link in the description. You can access all of those for free. And if you've really been enjoying the content so far and you're really serious about becoming an AI engineer, you might want to check out the Gen AI Accelerator, for which there's also a link in the description. We have an entire track to get you to a production-ready AI engineer. It has over 70 lessons, 40 hours of content, and we have a track record of 5-star reviews from developers just like you who came in with Python skills and knowledge and really wanted to level up their AI engineering skills. So if you're really serious about AI engineering and you're tired of browsing through endless tutorials and blog posts that don't really connect the dots and you just want to follow a proven 6-week track, then you might want to check out the link in the description to our Gen AI Accelerator program. All right, and with that introduction to LLM evaluations out of the way, let's now dive into the level 1 evals, creating scoped unit tests for large language models. And we're going to play with the following file over here. So this file is called LLM unit tests. It's in week 5 evals, and here it is. I'm going to walk you through a couple of examples that should provide you with a fundamental understanding of how this works and enough context for you now to create scope unit tests for your applications. So it's going to be pretty simple. And what we have over here is I have an evals folder, and in there I have an events folder with 3 sample JSON tickets. These are, of course, just for an example, but this when you're building an AI system, what you want to have in here are the exact raw events that your workflow accepts. So if you follow the project phase that we've been working with so far, this should really be your incoming event schema. And these should ideally be identified they should ideally be validated through a Pydantic model. so you exactly know what's flowing through your system. So here I have a simple example. We have a customer name, a message, a date, and a ticket ID, just to get a feel for things. Then I have a simple OpenAI client setup. I have a simple function to load the events, nothing more than getting the JSON in our memory. And then a very simple workflow, which is nothing more than a classification and a response generation to these events. So you're a customer service AI that analyzes customer queries. We ask it to create a category and a response. Not much to this, but the example can be extrapolated to any real workflow. The idea is take your incoming event and take it through your entire workflow, and then we're going to create tests around this. So let's start running through these one by one to get a feel for what this looks like. So here we are simply using the responses API to get structured output. Now, then we get to the testing part. So this is actually the new thing within this video. And if you are already familiar with assertions in Python, this is going to be very straightforward. But I created 3 test scenarios. So for every event that is in here, we have a simple test. We have a test for the billing, we have a test for the feature request, and we have a test for the support categorization, which is the one that we are going to fail, just to show you what this looks like. And what I'm going to do first is just start with the end in mind and run this thing to show you what this does. So this will loop over all the test examples, and then it will show you what works and what doesn't work. And now we have a 2 out of 3 test passed. But now let's dive a little bit deeper and see what we are actually doing here. So we are simply executing these tests one by one. So let's look at the test billing categorization and see what's going on. So first of all, we load the event. And this is nothing more than getting the JSON schema from the JSON file from our events folder. Then what we're doing is we're running our process customer message. So we are now getting a result back, which is our customer query, the response model, the structured output format that we have specified using the customer inquiry. So we can see that we have a category and we have a response. And now what we do is we create an assertion around the category, and we make sure, or we do a check to see if that's equal to billing. Now, if I do this, this will be true because the LLM, in this case, correctly identified the right category. So this will be true, which now means if I run this line in Python, it will simply it will pass. It will just run, but it will output nothing. And this is exactly how the assert function works. You simply do a test, and if the part behind the assert equals true, all good. If it's false, well, we can capture that and it will throw an error. So if I now, for example, say this is other, it will say an assertion error because this is not correct. And in a similar fashion, we can also check whether the length of the result or the response is, for example, greater than 10. So are we actually generating a reply? And we can run this as well because this is also true because this is actually 207. Now, by having this test over here, we can just loop over this and in this case have a very simple setup where we try to catch the error. So we can try and then run the test and we can print it. And if it's passed, we simply add 1 to this. And if it's an error, we catch the assertion error and we print what's going on. So this is really the most fundamental and simple possible way to set this up. You can go pretty deep in this just in the beginning alone, having a simple script where you have, 10, 20 of these cases that you understand, that you can frequently test, and that you can also expand as your workflow starts to grow in complexity, where you can guarantee that everything still works correctly. This is a very simple setup, but how this works in the real world is that currently we just have one step. So if we consider the workflow, there's just one call to OpenAI in this case, but you can extend this. And for every case that you have, you can look at your cognitive architecture and maybe you have 3, 5, maybe even 10 steps, and you can create assertions around every step in the same function. So you may know that for one particular event coming in, first there is a classification step, and that should be equal to billing. Then you use the router, and it should end up in the next step, where it's going to process that particular category. Now that will create an output and it will add it to, for example, the task context at the node level, at the result, you'll have another structured output object. Let's say with a reasoning or a confidence interval. You can check for that as well. Then you might generate an actual answer, which you can then check. And then you send it to a platform via an API call, and you capture the success, whether it's true or false, and you check against that. So I'm just giving some examples over here as to what you can add over here. And these can be really as big as you want. And the more stuff you add to this, the more strict your system and your tests become as you start to run this and start to work with this. Now, the setup that I have over here, just a simple file with a couple of functions and the events just here in my project, is usually good enough to start with. But as your system grows in complexity and you'll capture more and more of these events, you may also want to create a separate table within your database where you're going to store all of this and add metadata to it as well. So then you can essentially automate this whole process where you just capture it in the database. And for example, you plug the category already at the category level in another column. So you should really think about what makes most sense for your system. This is just the easiest way to get started with this. But as your system gets more serious, you may need to opt for more complex solutions in order to manage this effectively. I right now have the very most simple way of generating a test report, but you could also look into something like PyTest, which is the default library within Python to really create a proper testing setup. So this is the default for when you create really application or system level or feature level unit tests to see if your code still runs, to check data types, and you can apply the exact same principles for language models. So I typically just start off like this because it's super simple. If you want to see what this could look like with PyTest, simply take this file, plug it into your AI code editor, and then say, convert this test to a PyTest and give me a guide on how that works and how to run this. It will show you how to set it up. It's pretty simple. You need PyTest installed as a pip library. It will probably add some decorators and do an import. And then you have a systematic way that you can use to, for example, run all of the files within this folder just by running a terminal command, really. So the process is really the same. Doesn't really matter how you set it up. What you want to monitor for is follow the evaluation-driven workflow, right? So you want to analyze, you want to measure, and you want to improve. So what you want to do is you want to carefully monitor your system by either looking at the data or watching the failure modes, watching the failure patterns, getting feedback from users, then looking into LangChain, understanding the prompts and understanding the content as to what's going on. Then capture the raw events, either directly in your repository or put it into a database or directly from LangViews, and then create a test around this to see what is going wrong, identify the use case, and then start to play with your system prompts in order to try and solve this. And you first want to do this locally, so not directly on the production environment, so you break everything. You want to first isolate this example, you want to tweak it. Then now you have a new system prompt, maybe with some more examples, maybe with some more constraints, maybe a different model. And then once this test now passes, so you fix the issue, now run all of the other tests to see if they also still pass. That's the feedback cycle that you want to have in there, so that every time you come in here and you try to fix something, you have a guaranteed way of assessing all the other failure modes that you already tackled and already covered, and the common examples that your system can handle, that those also still work. So that's how you create LLM unit tests at the most foundational level. This was a simple introduction, but super effective and useful if you implement this correctly. We don't have any production system out there which doesn't have a folder with evals and events in there, so that as we we are developing and improving the system, we can always fall back to this and quickly test and iterate things. All right, and that's it for this entire crash course on LLM Evals. I hope that you found it valuable. I hope that you learned a ton. And if so, please leave a like and also consider subscribing. And if you want to continue your learning journey and also want to get practical examples on level 2, level 3 evals and how to integrate them with tools, as well as the entire 6-week roadmap for what it takes to become an AI engineer, then you might want to check out the Gen AI Accelerator program. So browse the landing page, see if it's something for you, see if it's something that makes sense. You won't regret it. It's one of the best things you can do right now to level up as an AI engineer. And if not, you can also, of course, just continue watching other videos here on my YouTube channel completely for free. So thank you for your attention. Thank you for watching, and then I'll see you in the next one.